everyone. Are we the only ones out there? I mean, come on, we've all asked ourselves that question at some point.
Right. It's like one of those big ones.
Totally. And today we're diving deep into how NASA plans to actually answer it,
Should be interesting.
to say the least.
Well,
We're talking about NASA's astrobiology program, their whole game plan for finding life beyond Earth. And let me tell you, this article we're looking at, it's got some seriously wild stuff in it.
like what? Give us a teaser.
Okay, you ready for this? Robotic worms. Alien photosynthesis. Things are about to get weird.
All right, you've got my attention.
This article, it blew my mind with just how strategic NASA is being about this whole search for life thing. This isn't just, gazing at stars and crossing their fingers.
No, they've been at this for a while. They've got a system.
Exactly. They have these things called decadal surveys.
Oh, yeah, I've heard of those. Basically, it's like every 10 years, all the big wigs in astronomy and biology and engineering, they get together.
For the best of the best.
Exactly. And they hammer out a plan for the next decade of space exploration. Like, what are the biggest questions? What missions should we prioritize? What technologies do we need to develop? It's all about focusing our efforts on the stuff that has the highest chance of actually finding life out there.
That makes a lot of sense. And it's not just about finding any life, right? It's about figuring out all the crazy places where life could exist.
100%. I mean, we're used to thinking about life on Earth, but the universe is full of possibilities. Planets with completely different atmospheres, different gravity, and then there's that icy moon.
Oh, yeah, you're talking about Enceladus, right? That one popped up in the article, and I gotta say, I was surprised by how excited people are about it. Why is that moon such a big deal in the whole astrobiology world?
Okay, so picture this, right? You got this moon, Enceladus, covered in ice. Not exactly what you think of when you think of a bustling alien ecosystem, right?
Yeah, really.
But under all that ice and massive ocean, like a hidden ocean just chilling beneath the surface.
Whoa, wait, how do we even know it's there?
That's where it gets really cool. Enceladus has these huge plumes of water vapor that just erupt from its south pole. Basically, it's like Enceladus is shooting out samples of this hidden ocean straight into space.
It's like a cosmic message in a bottle.
Oh, kind of, yeah. A giant one that we can actually see with telescopes.
So it's like Enceladus is basically waving at us, saying, hey, come check this out. But okay, let's say we get through all that ice, get into that hidden ocean. What are we even looking for? What would life on Enceladus or any other world even look like?
See, that's where things get really interesting, because it might not look anything like what we're used to.
No little green men?
I mean, maybe. Who knows? But probably not.
Right.
We're so used to life on Earth, but life on other planets, it wouldn't have gone through the same evolutionary journey, It could be wildly different, stranger than anything we can even imagine.
Okay, that's both cool and kind of terrifying. So like a world with different gravity, different atmosphere, that would mean some pretty crazy adaptations, right?
Absolutely.
Yeah.
I mean, think about it. The creatures we consider normal here, they're the way they are because of billions of years adapting to this planet.
Makes sense.
Different environment, different rules, totally different life forms. And that begs the question, are there any universal constants when it comes to life?
Like, no matter how alien it gets, there's some things that are just going to evolve no matter what.
Exactly. Some scientists think so. Maybe because of the laws of physics or the elements that are just abundant in the universe, certain things are more likely to pop up, like photosynthesis.
Right. Plants using sunlight for energy.
Yeah, stars are these massive energy sources. It wouldn't be surprising if life on other planets evolved to capture that energy, just like plants did here.
So alien plants might not be green, but they'd still need a way to soak up that starlight.
Exactly. And imagine their version of photosynthesis. Maybe they've got these crazy pigments we can't even see, or they use a totally different kind of energy.
So we could be looking for life as we know it and miss the life forms that are right in front of us.
It's a huge challenge. How do you search for something you can't even fathom?
Okay, enough philosophy for now. Let's talk about Enceladus again. How are we gonna actually investigate an ocean that's buried under miles of ice?
Well, remember those plumes of water vapor? They're not just pretty, they're an opportunity. We can analyze them, get an idea of what's in that ocean without digging through all that ice.
So free samples?
Kind of. And NASA's coming up with some pretty wild ideas, like sending a robotic probe through those plumes.
Okay, now that sounds like science fiction.
Right. This probe would navigate that plume and maybe even, get this, burrow into the ocean itself.
Wait, like a robotic worm burrowing through an alien ocean searching for life? That's straight out of a movie.
It's pretty wild, but they're serious. This thing would have to navigate some crazy terrain, collect data, send it back to us. It's incredible.
Okay, that's seriously cool. But it makes you think, what if we find alien life not out in space, but make it right here?
You're talking about synthetic biology.
Synthetic biology. Okay, you're going to have to break that one down for me. It sounds like, I don't know, something out of Star Trek.
Right. But this is actually happening right now. It's wild. Basically, we're talking about scientists. They're figuring out the basic building blocks of life, like at the most fundamental level.
Okay, and then?
And then they're using that knowledge to try and create totally new life forms right here in the lab.
So not just finding life, building it from scratch. My mind is kind of blown right now.
It's pretty crazy stuff. Makes you wonder, what if somewhere out there on some other planet, there's another intelligent species doing the exact same thing? What if we're the aliens in their science experiment?
Whoa, okay. Now that is a thought. But it brings up another question. Let's say we do find life out there, swimming around in Enceladus's ocean, hanging out on some distant planet, however it goes down. How do we even begin to talk to them?
The million-dollar question. How do you communicate with something that could be totally different from anything you've ever encountered?
Yeah.
And they don't exactly have intergalactic dictionaries lying around.
Yeah, no universal translators like in the movies.
Wouldn't that be nice?
Yeah.
Actually, you know who have an interesting idea about this? Neil deGrasse Tyson. He thinks math might be the universal language.
Math. Really? You're going to have to explain that one to me.
Think about it. Math, it's all about patterns, ratios, shapes, things that exist no matter where you are in the universe.
So a circle on Earth is the same as a circle wherever.
Exactly. The ratio of a circle's circumference to its diameter, pi, that's a universal constant. Prime numbers, the Fibonacci sequence, geometry, all of that is built into the universe. It's not something we made up, it's something we discovered. And if other intelligent life is out there, it stands to reason they'd discover the same things.
So instead of sending out a message, we should be beaming out equations.
Well, it's more complicated than that. But the idea is we'd be looking for patterns in signals from space, something that shows an understanding of these mathematical principles.
Like a cosmic code. Wow. Math, the key to talking to aliens. Never thought of it that way. This whole deep dive has been amazing. We started out asking if we're alone in the universe, and now, well, it feels like anything is possible.
Right.
NASA's out there with their master plan. We've got scientists cooking up new life in labs. And maybe, just maybe, math is the key to joining the galactic conversation. It's pretty mind-blowing stuff. So to everyone listening, keep looking up, keep asking those big questions, and who knows what we'll discover next. Until next time, thanks for joining us.